Hey, this is Claude. Today, what I want to talk about a little bit is on some BGP traffic manipulation. To be more specific, utilizing the BGP attributes to steer traffic in a given way that you see fit. So, just to open it up a little bit, give a little context, what we're going to be talking about are BGP attributes that are classified in the well known mandatory, which means nothing more than basically all of the BGP speakers within that given domain, within that given network, are capable of passing these specific attributes that's in question. To drill down even further, what we're going to be looking at are, like I said, the well-known mandatory, but in this case, what we're going to be utilizing is this here one that you see at the top, the origin code. Okay, and what we'll do is you'll see how the origin code affects the direction in which traffic traverses through the network. Okay, so what we're gonna just to give you a little idea, what we have is a topology here. In my lab, we're using actual real gear, Cisco gear, but this is what the topology looks like here. We have four routers, and we'll call them J1 through J4. Okay, and what you'll see is the networks in between these here eBGP speakers. Each one is its own autonomous system. So this is purely a eBGP environment. Okay. And each one has a loopback that designates, 10, 20, 30, 40, which designates, literally the router itself. Router 1, router 2, router 3, router 4. You get the idea. The networks in between that we're dealing with is the 15 network between the neighbors of J2 and J4, the 10 network between the neighbors of J3 and J4, and you can see the networks towards the bottom of the topology, the 21 net and the 31 net for neighbors J2 and J3 respectively from J1. Okay, so what we'll do is we'll talk about how traffic is seen when we want when loopback 1010 wants to talk to loopback 4040. Okay. So if J1 wants to talk to J4, how does that happen currently by default? Okay. So what we'll do is we'll take a look and you'll see that this loopback here is up here on J4. Okay. And at the same time, let me just add a little bit more context to this here. So what you'll see is loopback 0 on J4 indicated with the IP address of 4040. Okay, 404040. And you'll see the actual networks between the links between the neighbors. Okay, the last octet will pretty much tell you which router that is. So no matter what IP you see, that last octet will give you clue as to which router it is. Okay, so currently, let's just take a peek. Like I said, we want to be able to go from J1 to J4. And what we want to do is we want to see how that's currently done now. So let's do a show IP BGP. And what you will see in the BGP table that to get to J4's loopback, we have two different ways that we can go. We can go through J3 or J2, which is simply defined just like you see here. Okay. So we got multipath set up in the BGP configuration. So we can choose either 21 net or the 31 net. Okay. And as you see, they're going to run through their respective autonomous systems. Okay. Router 3, autonomous system 103. Router 2, autonomous system 102. okay, to reach autonomous system 4, which is J4 itself. Now, as you see, we got the little symbol here that lets us know the best path that has actually been selected for this to happen, okay, and that's through router number 2. Okay, we can clearly see that. All right, and we can actually confirm that by doing a trace route to 40, 40, 40, 40, and we'll get that confirmed as well. You'll see that we're going to traverse through router 2, then to get to router 4. All right, just like what you see here in the topology. We're going to go to J2, then to J4. Okay, that's by default. Okay, why that is by default, that's a whole nother lesson in itself. But in short, once you run through the different path selection of how BGP actually selects its path, when you run through, when everything is the same, you running through weight, local preference, med, all that good stuff. You kind of get down towards the tail end, and what you'll get to is the router ID. Okay, and the lowest router ID will actually win that path selection for you. Okay, so just for giggles, when you look at the router IDs include ID, you'll see that J3 is the 3030, and like I mentioned before, J2, which is off screen, let me pull that in here. Okay, and what you'll see here is showing IPBGP include ID. You'll see 2020 there. So you can clearly see if we're going to go by the lowest router ID, J2 wins that bout, okay, which is why traffic by default is going there. All right, so let's do this. How can we use the origin code to manipulate this traffic so that it won't go to J2, but will traverse through J3 to get to our 4040 destination? Okay, now let's do this. We're going to show IPBGP 4040. Okay, and what we see here is it's telling us it has two available paths. Like I told you before, we got multi-path uh, selection on right here. Okay, these routers are configured to utilize multiple paths to get to a given destination. We already stated that this was the router 2 was the best route. But what we need to focus on is the origin code. Okay, in this case, it says incomplete. Okay, so there's three different types of origin codes that we're going to be looking for. IGP, IGP, which is nothing but a interior gateway protocol, which states that this specific prefix or this specific route has an origin code that came from an interior gateway protocol. Okay. Uh, then there's an EBGP, no, an exterior gateway protocol, EGP. Okay, which may come through some sort of distribution from another uh, routing protocol or something like that. And then you have your incomplete. Okay, and a lot of times this here incomplete is set up through something that's known as a redistribution. Okay, and basically prefixes and routes that are redistributed into the domain will come up with the incomplete origin code. Okay, now what we want to do is we want to change how J1 sees the routes, or I should say the origin code to get to the route and to get to its destination 4040. Currently, right now, they're both the same. Like I said, when everything's all the same and equal, you go down that list and then you're going to run into the lowest router ID, which is going to, be the tiebreaker of determining how I'm going to send my traffic to get to 4040. So what we need to do is we're going to utilize a route map within J3, okay, because we want J3 to influence the path selection to take that traffic away from J2's plate and bring it to J3. Okay, and how we're going to utilize that is, for one, we have to identify this route, this prefix. Okay, and we're going to use a prefix list for that. Okay, and like I said, J3 is going to be actually looking for that advertisement of 4040 from J4. So I've already put this in here, and what we're going to do is we're going to do a show IP prefix list. And what you will see is that there's a prefix list that is set up right now to look for this 4040 network. Okay. So with that being said, we just can't stop it there. We got to there's some other things we got to do as well. Okay. So we actually also have to apply a route map. Okay. And if you're this far in the game and don't understand when I say a route map, I don't know what to say at this point. But you just got to go back and check out a few things and do a little bit more reading. But what we're going to do is we're going to use a route map, okay, to actually apply that to a BGP neighbor. So let's just do see what route maps we have in here. Okay. Now we this kill 15 is something different. That's something for another lab. But for our purposes here pertaining to prefix list net 40, we're looking at route map autonomous system 104. Okay. And in this route map, what we're going to do is we're going to match the IP prefix list net 40, which was defined up here in this here prefix list. Okay. So first thing we're going to do, we're going to look to see for that advertisement. Okay. Net 40. That's what we call in the prefix list, net 40. And within net 40, we're looking for the prefix 404040. Okay. What we're going to do at that point is we're going to take an action. And that action is basically to rewrite that origin code to IGP, Interior Gateway Protocol. Okay, so we're going to make it look like something else. Okay, so J3 is going to get information about J4, rewrite that information, then turn around and tell J1 something different. In layman's terms, that's what's going to happen. Okay, so and what this is going to do, this is going to influence our path from J1 to J4 to get the 440 by going through J3 and not J2. Okay. So what we got to do here is we got to apply this to an actual neighbor. You got to apply these rules to a certain neighbor. And in this case, 440 is coming from J4. So we want to actually apply this to the J4 neighbor. So let's just take a look at section BGP. We're going to take a look at our BGP section. And what we're going to do is we're going to apply this to the neighbor 10004. Okay. And that's what we want to apply this route map to. So what that's going to look like is we're going to go config. I'm going to go router BGP 103. Okay. And what we're going to do is we're going to go neighbor 10004 route map autonomous system, which was the name of the one in question. And what we got a choice here. So what we're looking for is we're looking for the advertisement in to us from J4. Okay. So in this case, it's going to be an in. All right. And we're going to hit that there and it accepts it. And then we go ahead and hit that in. Let's just check and make sure that it took. Show run BGP section BGP. And then you go right here. So we have that route map that's now applied to our neighbor at J4. Like I said, what we're looking to do is to manipulate that traffic that was by default going to J2. Okay, what you see down here on the IBGP table. for 4040, the best path was router number 2. And what we want to do is we want to change that. So what we're going to do is we're going to do a clear, all right, IP BGP asterisk, and we're going to do a soft, okay? And this is nothing more than basically updating the outbound and inbound advertisements from the neighbors, okay? So just remember, you can do one or two things. You can do a clear IBGP, which is a violent tear down, okay, where your neighbors will actually go down and then come back up. Uh, definitely not. That's definitely something you need to think about if you're in a production environment. Seriously. But with the soft method does it, but it keeps the connections, it keeps the neighborships up. But what it does, it looks for fresh updates, so that so basically your connections stay up, but it's looking for fresh updates, any changes of any information that's coming about. Okay. So now, with that being done, what we want to do is we want to take a look at how J1 sees its path to 4040 again. So let's go ahead and take that same command. All right. Now what you see is where before J2 was the best route. Now what you see is J3. Now we go from an incomplete status to an origin code of IGP, okay, which is letting us know now that is our best route, okay. So where you saw the trace route before, first hop, router number 2 to get to router number 4, let's take a look at that now and see what that looks like on the trace route. So now here we are going to J3, now to J4, okay. So like I said, we went from watching our traffic by default go from J1 to J2, then to J4 to its destination of 4040. Now, through manipulating the origin code, we can now see that that traffic clearly goes to J3, now to J4 to get to its final destination of the loopback 4040. So, in a nutshell, J3 received its advertisement from J4 of what the 4040 network was as far as its origin code, changed it, then turned around and told J1, hey, look, I got a much better path here than J2. Why don't you send that traffic to get to 4040 through me and I'll take care of you. Okay. So, like I said, in a nutshell, that's utilizing the origin code and BGP and a BGP attribute, a well known BGP attribute to manipulate traffic. Hope you get the idea. And like I said, experiment. Some of you are probably actually utilizing this already in your production networks. But like I said, this is just one of the many ways of manipulating traffic in the BGP environment. Until next time, take care.